Welcome back, everybody. The first video you watched was about translations and dilation. Today we're going to continue with transformations. We're going to talk about reflection. So before we talk about reflection, you're probably imagining somebody looking in a mirror when you think of the word reflection. And that's good because that'll help us with the idea of what we're trying to do today. So before we get started, I want you to imagine that this Halloween you decide you're going to be a pirate. So you get your pirate costume out, you've got your hat and your eye patch and a parrot and a hook, and you've got a little peg leg going on too. And you look at yourself in the mirror to see exactly how well your costume's coming out. And at the moment you're standing 10 feet away from this full-length mirror. Now, I want you to imagine something. How far does it look like your reflection is standing behind the mirror? Does it look like they're right at the mirror? As if they're standing, if that was a person, they would be right where the mirror is standing? Would it look like they're standing 10 feet behind the mirror? So if you imagine this was a window, it would look like they were 10 feet behind it? Or would it look like they were 20 feet behind the window? So if you were looking through, you'd see the window, and then they'd be another 20 feet beyond that. So I want you to sit and mull that over for a minute or two. So hopefully we can pause this video. And hopefully that's enough time. Hopefully you've paused and you've come back now. Now, I'm sure some of you are imagining one of the three options. I'm sure it's not unanimous. But ultimately, what you would hopefully come up with is that you would not look like you're 20 feet beyond the mirror, nor would you look like you're right behind it. You would look like you're 10 feet away because you're currently standing 10 feet away. And that's the idea with reflection. However far we are away from what's doing the reflecting, in this case a mirror, it's going to look like our image on the other side is going to be that same distance away, but on the other side. So if you've ever gone to a mirror and you've gotten really close to it, right up next to it, it looks like that person is right up next to it, and then as you move further away, your reflection, that other person appears like they're moving further away too. So that's what's going on here. But there's also something a little weird, and I'm taping these out of order, so you guys can keep an eye out for it. When you're doing trigonometry, I had to show a calculator to the camcorder. So I took a calculator and I held it up like this. The problem was I couldn't quite figure out whether to move it this way or that way because I'm staring at a screen that's right next to the camcorder. So I'm looking at that and I want to go this way, but in reality I go that way. And I spend the whole time awkwardly holding the calculator. I should probably retape it. I probably won't have time to do so. But you'll see it, look for it, you'll notice it then. Why is that? Well, it's because I'm really seeing a reflection in that, or I'm really seeing what's there in the screen that I'm looking at, when I'm used to seeing a reflection of myself. Some of you guys might notice this. If you've ever had to do something in the mirror that you're not used to doing. So I know when I first started shaving, that was an issue. Having to go in the correct direction. You're looking at yourself in the mirror and you want to go in a different direction. Or maybe if you've ever tried to put something on your head and try to find exactly where it is and maneuver it and twist it, it's a little backwards from what you're used to. The reason for that is what's going to go on with the reflection. So I want you to think about this for a second. Look at this hook. Is that hook going to be in the near hand here or the far hand there? So which hand is it going to look like if you're looking in the mirror? Is it going to appear that the hook is on? So again, take a second or two, think about that. Okay, hopefully you've had time to think. And hopefully what you've recognized, if you've ever had any experience in front of a mirror, is that our hook's on the far hand here, it will appear like it's on the far hand there. So if it's on your right hand here, it will look like your mirror image has it on their left hand. Okay, and by all means try it when you get home in front of a mirror to see exactly what's going on. But that's what it'll appear like. If you stand like this in front of a mirror so that one hand's further back, one hand's up close, if you have something like a marker in your far hand, it will appear like your reflection has the marker in their far hand, but it won't be the same hand left and right, it'll be the opposite. So that's what's going on here. When we reflect, our shape is going to look like it's going in the opposite direction that we're seeing. So everything that was on the left side now appears like it's on the right side. But other than that, it looks exactly the same and it looks a comparable distance away. So that's what's going on. Hopefully that makes some sense as far as what we're going to be looking at. So now we're going to go into how to find it with shapes. What are we actually using it for? So we're going to take this shape, this trapezoid here, and we're going to reflect it. Now we can reflect it a couple different ways. You could reflect it in the x or the y axis. We'll talk about that quickly. You could reflect it on a vertical or horizontal line that's given to you. For instance, this one, y equals 2. You could reflect it on that. It's a little different. You could also reflect across the line, the diagonal line, y equals x or y equals negative x. We'll talk about all of those things. So the first example I'm going to show you is what happens when you reflect across the x or the y axis. So let's focus by reflecting across the y axis first, just so you can see what's going on. So with this picture in mind, and with these coordinates in mind, so we have our coordinates just like we did the other day when we were doing translation and dilation. We have our coordinates listed, and now what we want to do is look at what's going on. So the whole process for reflection is just going to be find out how far away from the line of reflection you are, and then go that same distance in the opposite direction, just like you would when you're looking at yourself in a mirror. So we want to take point A, for instance, and we're just going to go to the line of reflection if we decide to reflect across the y-axis. And then we're going to count that same distance in the opposite direction. So for this example, we're going to reflect across the y-axis, and we're just going to count. So A is at -6, 3. So we're at -6, 3. Hopefully you recognize that if we're reflecting across this axis, this shape is not going to be going up or down. It's going to be staying the same height as far as the coordinates go. What is going to change is how far left or right it is and the direction that it's facing. So what we're going to do is we're just going to focus on the x-axis, or the x value. The y value will stay the same. So what you'll find for all of these is that our y values are going to stay exactly the same. It's the x values that will change. And the reason is we're not moving the shape up and down. We're just moving it side to side. So we take a look at point A and we want to go, okay, how far have we gone? So we count. We've gone 1, 2, 3, 4, 5, 6. We've been 6 boxes over from our reflection line, our line of reflection. So now what we're going to do is we're going to count that same distance in the opposite direction. So we go 1, 2, 3, 4, 5, 6. We find that point 6. There's our A prime. Okay? So what we're going to find is we're at +6, +3. All right? We'll take a look at B. We'll do the same thing. So B was at -4, 8. So what we're going to do, we know the 8's not going to change. It's going to stay the same height. So up and down won't change. Side to side will. We went 1, 2, 3, 4. So we went 4 to get to our line of reflection. We're going to go 4 the other way. 1, 2, 3, 4. That's going to be our B prime. And what you're going to notice when you reflect in the x-axis or the y-axis is that one of your values won't change, and the other value, the only thing that changes is the sign. So without even doing the others, I'm going to know that we're at 2, 8 and we're at 2, 3. Because I know to get to this line, which is going to be when the x value is at 0, I have to go 2. I'm going to go 2 the other way. So that's what we do. There's our C prime. And here's our D prime. And when you connect it, you'll see we get the same shape. It's just reflected. It's facing the opposite direction. It's the same distance away from our reflection line, which acts like a mirror. So that's the first example of a reflection that we're going to see, across either the x or the y-axis. Now if we reflected across the y-axis, our up and down would be changing, so our y values would change. Our side to side would not. So our x's would have stayed the same, but we would have changed the sign of our y's. So for those of you wondering, well, what's the difference? That would be the difference. What we're going to do now, though, is I'm going to take these down, and we're going to talk about what happens when we reflect across not just one of the axes, but just any vertical or horizontal line that we're given. So we have this line over here, y equals 2. So if we took that line and we were going to reflect across it, again, all we're going to do is count. How far are we going? So A, our A values, we're going down to get to our line of reflection. So are we moving side to side? No. Which means our x values should stay the same here. So -6, -4, -2, -2. Our y values in this case are going to change the same. So again, figure out how far are you going and in what direction are you going. If it's a vertical or horizontal line, only one of your x or y values will change. The other one will stay the same. In this case, our x values are going to stay the same. Our y values are going to change. So here is A. Our x value is still going to be -6. We went down 1. We're going to go down 1 again. There's A prime. So we just counted how far did we go? We went down 1. How far do we have to go? We have to go down 1. That's it. So there's our A prime. You could do the same thing with D prime over here. That one's easy to see. So there's A prime and there's D prime. We're going to do it with B prime now. B prime was at 8. So, or B was at 8. So figure out from 8, if we had to get to 2, we're going to go down 6. So now we're going to go down another 6 from 2. That's going to put us at -4. So we're going to be right here. That's going to be our B prime. And then C prime, again, was at 8, so we went down 6. We're going to go down another 6 to -4. And I'm a little low, it looks like. So there's our C prime. And then all we have to do is just connect the dots, connect our points, and we'll have our shape. And when you're done, you'll notice again, you will get the same exact shape, but you'll get a mirror image. So you can almost imagine that if this trapezoid was looking into a lake and it saw its reflection in the lake, this is exactly what it would see. All right, same idea. So that's the whole idea behind reflection. You just want to figure out, okay, how far are we going and in what direction? And that's going to let us know whether we're going to change our x values or our y values. So that's it as far as reflections with vertical or horizontal lines. Now, there's one kind of reflection that we're going to see that uses a diagonal line, and it's based off the diagonal line y equals x. You could also see y equals -x, but it's the same idea. So I'm going to erase this quickly. I just erased the shape I was hoping to leave up. So we'll plot this out again. We've got our A prime at -6, 3. We've got our D prime at -2, 3. Oh, or I'm sorry, just D. It's not D prime. Okay, so there's our shape. What I'm going to do now is I'm going to draw the line for y equals x. So y equals x is just a diagonal line that passes through the origin. It has a slope of 1. There's our reflection line. It's going to be y equals x. Now, this is pretty simple too, even though it doesn't look it. The reflection line is telling you everything you need to know here. It's going to tell you that the y value is now going to become the x value, and the x value is now going to become the y value. So if you want to plot this, all you have to do is just flip-flop the x and y values. You would get 3, -6, you would get 8, -4, you would get 8, -2, and we would get 3, -2. All we did was we took the x and y values and flipped them. And what you'll notice when we do that, we're going to get this. We're going to go 3, -6, going to see 8, negative 4. We're going to see 8, negative 2. And we're going to see 3, negative 2. And you'll notice the shape we get is going to be A prime, B prime, C prime, D prime. It's going to be the same exact shape, but you'll notice it's reflected now across that diagonal line. If you had y equals negative x, you'd do the same thing, but keep in mind, because it's a negative x, you would want to change the sign of both of the values when you flip them. But that's all you really need to do. The reason for that is, in this case, we're counting how far we're going for the c values. Now you'll notice you have changed your x values, but your y values have stayed the same. What's happening though is as we reflect, and I know this isn't drawn to scale, but you'll get the idea. As we reflect across that diagonal line, what you're going to see is that we're now, instead of going side to side, we're going to be going up and down. All right? So think about what happens if you reflect across a mirror, but you tilt it. So if you've ever used a mirror to look at so that you could look up at something, if it's tilted diagonally, you're able to do that. That's what's going on here. You can imagine that if we had a mirror tilted downwards as we were looking in this direction. So here's our mirror tilted downwards. As we look, we're looking horizontally, it hits the mirror, and now we're able to look down. All right? That's what's going on here. That's our reflection through a diagonal line. The only lines you're going to be responsible for are vertical and horizontal lines of any kind, so either through the x-axis, through the y-axis, or any vertical or horizontal line other than the x and y-axis, and then this one specific diagonal line. So as far as reflection goes, that's what you're going to be asked to do. So just to recap, for going through y equals x, all you have to do is just flip the x and y values. If you had a vertical line or a horizontal line, all you have to do, count how far you're going to it, count how far from that line you just went. So if you went 2 to get to the line you needed to go to, you count 2 in the opposite direction, you put your point, you list your point. And that's all there is to it. If you have any questions, rewind the tape, watch it again. If not, I should be around for extra help soon. Until then, I'll see you later.